right, so now that we're recording, I just want to reiterate a welcome and many thanks for joining us. We are at the November 2025 GOSH Community Call where we're featuring Julien and his work on his hardware documentation guide. So the way that we'll structure this is Julien is our featured speaker today. So feel free to take as much time as you need to present your work, and hopefully reserve a few minutes at the end for some question and answer. I know that we have some people who are really excited about this conversation today. So thanks again for joining us, and thank you everybody who's dialed in so far as well. Julien, you can go ahead and get started. Please.
Yeah, thank you for the opportunity to show the advance of this work on open hardware documentation. I'll try to see if this work. Shall I try this? Do you see my screen?
Yes.
Good. So thank you for being there. Welcome, Nicolas. We met in Delft, so I think you remember. And Michael will meet next week at the shop. So sorry for you. It will be, unless there is a lot of feedback, it will be the same talk next week. So this to show about our work in the OpenMake project about the guide for open hardware documentation. So I'm working with Robert Mies that people usually know in the community that worked on the OpenOmeter and other documentation related work inside the OpenNext project and now inside the Louds Factories project, so two EU projects linked to open source hardware. So I'll talk a little bit about the team while then jumping into why we document hardware and then give the sources of that this work is based on, and then present the guide itself and try to make as much space as possible for discussions. So this work was done inside two projects. The first one is OpenMake, which is a Berlin-based project which works on open source hardware in academia. So we want to work on making it easier for people to publish hardware and to be recognized for these publications. And inside that, we have a community building aspect, and we do a teaching and networking with the world, which is why I'm here today, right? The second project is an EU project called Louds Factories. There's different partners in Europe, and we work more into maker spaces and transforming maker spaces into mini factories and looking into what is necessary to make this step from prototyping to small scale manufacturing. And inside those two projects, documentation of the hardware is basically a center element, because that's how you get your work recognized, basically. And when we see about why people documenting hardware in the GOSH community and in many open source hardware communities, people will always take for granted that it's about making reuse using the freedoms of open source hardware and all this open science aspect, which is about transparency of the work and making it reproducible. But I would say there is a more or let's say more personal interest into documenting, which is that your first collaborator is your future selves, and especially in hardware, or in open hardware, usually there's long breaks between different versions of the hardware. People work on it for a couple of weeks and let it aside and come back to it 2 months later. And if documentation has not been done, then you basically have to start from scratch. And that's the basics of research data management too. So that's why it took a big part of the stewardship or the support staff in academia is involved a lot with research data management, how to make a data reusable and on a long-term perspective. But if we ask people which published hardware or shared hardware for their motivation, or if we, so this is a base, it's an analysis of interviews that was not directly linked to the motivation, but we basically took the interviews and reworked it to answer this question of why people will publish their hardware. And interestingly, there is three main elements. One's about the hardware itself and the community around the hardware. So people want a bigger community to be able to get better hardware, or a project which has more meaning in terms of the community. Then there's more personal interest and career development to get recognition, but also to learn new things. And having fun is a very important element in the open source hardware community. The third element is basically values and long-term vision. People do that because they think it's the right thing to do. And make a small detour about the difference between cooperation and collaboration, because I think it's quite important to understand that you can document towards different goals. And if you only want to get to the cooperation stage, where basically it's about the hardware reused by others and working together toward a goal which is defined before, then you don't need as much documentation or a different documentation as if you want to foster collaboration, which there it's about not only working toward the same goal, but really working into defining those goals together and making the goals evolve through time when new people enter the community that is collaborating. Right, so that is an introduction about the background of this work. And this slide is about the sources I used. The first one is OpenNext hardware documentation template that was created during the OpenNext project 2-3 years ago, and which was created by people which were involved a lot with co-design, and that keeps an emphasis on how to document a template or how to document an hardware such that it makes designing together easier. Then we looked at the templates of the academic journals, so the Journal of Open Hardware and Hardware X. We looked up about what we could find in the Turek book, and Nicolas Mendes was there with us when we wrote this chapter in open source hardware, where we defined quite a lot of things about hardware specifics, but also in the Turing Way book itself, there was already quite a lot of content about open source projects and open science projects. Then we looked into more technical documentation templates like the OpenKnow manifest and its derivative form for the library of open source hardware. We looked at OHO, the Open Hardware Observatory, what they had there, and then look at the OSHPA certification process and guidelines and the DIN spec 3105, I think is the right number. So, and at each step, I added new elements, and for each element now in the guide, we'll have some description of the element, and then the guide starts with when to do what. And that's basically the first introduction I want to do to the guide, is the stages of development of an hardware. That's quite important to know when you have to document, because at different stages the documentation will look different, basically. And so that's a work from the OpenNext project I spoke about before, from mainly from Jean-François Bourjus, where they define the different, or they reuse different steps which are known to be there in design. So there's first the ID generation, and then there's a specification, which is basically an analysis of the user needs. That leads to the definition of requirements. And then when you have the requirements, there's the development of a concept. And when the concept is ready, there is first prototyping. And when you choose a good prototype, then it gets to the replication phase. So that's one degree of liberty, I would say, for the documentation. The second degree of liberty is the aims, or the main aim of an element of the documentation. And here I could define 5 different categories, I would say. The first one is about developing the community. The second one is in blue here on the right. It's a business development aspect. So that this goes beyond defining what is the revenue flow, but really look at what the user needs is, who are the people involved, and this business is there thought as a large concept. Then there is a technical development itself, which is is about CAD files and this kind of development, really about the hardware itself. Then there are elements which are not for the development, but really for the production of the hardware. And the last one is about the usage of the hardware. And if we combine those 2 elements, we can see through time. So this would be for the first step. So ID, you have to document the vision, the team and resources. Right? The vision is about the project itself and the hardware, the technical, basically the technical documentation, while information about the team and the resources is more about community, and that newcomers can know who is involved and what they can expect. So at this stage, it's really about setting an ID with your team and bringing new people in if you need. For the specification, it's basically a needs analysis and a description of the problem. And this can be quite complex because you have to consider very different aspects to it. What is the technical or social ecosystem, but also you can involve a lot of different people, not only the designers and the users, but also producers, maintainers, and future recyclers of the product. Then you define what skills people will need to use the hardware and how they will interact with the hardware to derive requirement constraints and capabilities, which is the main output of this stage. Then comes the concept development, and this the stage where you try to modularize the hardware to make it for each problem basically a smaller part which you can combine together. It's this step is also about looking for existing solutions and use cases. And here from the OpenNext work, they propose to use a functional behavioral structural model to define how the hardware will work. So this is basically a concept where you look first at what the hardware should do, so it's a function, and then you look at how it should behave to be able to do that. That's a behavioral aspect, which is often stayed very unconscious in the mind of the engineers, but can be interesting to have it in text and described. And from this, you define a structure of your hardware. And from there, you can come back, and it's a bit iterative until you get a concept. Right, and then once you have a concept, you basically look more in detail into the architecture, you create these CAD design files, you choose the materials, and then in black here's the core of what the open source hardware is in the OSHVA definition, which is a bill of materials, technical drawings, software that are involved in working the hardware. At this step, you probably need a manufacturing and assembly guide, and maybe a user guide, depending on the hardware. And at this step, you have the first prototype, the first feedback, and it's iterative, usually for different prototypes until you have one that go into the next stage, which makes it a bit more market ready. And then you have different guides you add to that for maintenance, disassembly, repair, recycling. You have, if it's a research hardware, especially some information about the validation and discussion of if the hardware works or not and for what it's made. You may have a research paper that you want people to cite, and you may also, if your hardware is collecting data, to have that's pretty important. So there's this description of the hardware output, and if it's data, an example of the data, so that people can work on the data stream without having to have the hardware. Right, and that's the basics of what is inside the documentation guide. It's in the form of a book, which is available. I'll give I think the links come later, but it's basically a quarter book. So in the technical aspect, behind it, it's markdown files that are put together into a book. And the book starts with an introduction about what I just explained now, and then comes to the development stage. And for each stage, there's a checklist of things that you can add. And for each of those elements, there is a part of the book that describe it and give examples. I mean, for most of them, there are also examples. This comes with a template also, and there's these two versions. On one side, there's a full template, so how it could look with a very advanced project with a large README and different folders giving different information needed. And we also have a template which is incremental. So the idea there is that you start by the ideation, which is basically there your documentation is one README file, which can be very short. And at each step of development, you add elements to the README and to the repository itself, so that it grow at each step to get to a situation where the full template is. Right. So it's an open project. So I think this QR code will lead you to the hardware documentation. I can also put it in the chat afterwards if you want to look at it in more details and discuss it in more details. And in the end, as a summary, we have this open hardware developmental practice, which are derived from open science, which means both in terms of transparency and making things reusable, but also making things inclusive that everybody can use and also be part of the creation of those open hardware. And this leads to reuse and collaboration in the process of developing the hardware. And outside the academic system, it can be sold as a decrease in time to market, increase in sustainability and in quality of the hardware. That's the main goal when we speak to the industry or to open source hardware in industrial context. And I think I'm already over, right? And I stop sharing. And I think the best is I've put the link in the chat, and then we can discuss. I have another problem now. So Nicola, maybe you start by.
Hi.
I remember we discussed some of that in depth at the time, right?
How are you doing, Julien?
Okay-ish. I'm in the lab, so
Okay.
that's crazy. No cat for me today.
She needs her spot. Yeah, I remember a bit about that, and I just well, first, thanks for sharing everything. I see that it goes into uh, depths that I didn't know existed, because I always start I always start at of the stages you described. I always start at the last one. uh, so I bet there's lots for me to learn from that. Well, I'm not an engineer like the guy from YouTube says, so I just get just go usually. So I shared just two links that at the time uh, we were and that we met. I prepared for a group of students that were working on the liquid handler project. So these were like students from several places, several different careers. So biotech, engineering, and others. And they had to work together. So we decided on a system of documentation that works sort of like a form, which I've shared in the, and it's basically a more organized version of what we discussed at the time at Delft. And it has like headings, and it says overview, usage, limitations, assembly, installation, interaction. So all of the things that more or less are needed for it to sort of work, and it worked. So the people documented their daily work on Discord, uh, because it's easy, and you get multimedia archiving of what you're doing very easily. So you take a picture, you take a video, you took an audio note, and you just upload it, and then 10 days later, they dumped all of that into the documentation template I shared. And that worked. And that's what I have to share, really, as an update. It's very little compared to your work, but it was great. I wonder what you feel would. So all the previous part of what you showed. So I have trouble, because I'm not an engineer. Perhaps I have trouble relating to it a little bit. So what would be like some first steps for someone like me to approach the hardware documentation guide?
Mhm. So I think there's different aspect to it, right? So there's a lot of the work that has been done in terms of documentation is meant to have a documentation which is there for a long time and can be reused 3 years later by a different group. And with this work, I try to also include things usually document for people to help the collaboration in the design itself. So during the creation of the hardware, or during the creation of the community around the hardware project, you have a lot of things which are usually not documented and which makes it difficult for new people to come in, because you basically already have your community and it's not meant for new people to come in. And you have a lot of unspoken rules, and maybe you knew already the people before you started the project, and then you don't do that. And that's something which is not specific to hardware. People have the same kind of questions for software or for other scientific or research endeavors. When you want to grow your team or to work collaboratively, you have a lot of community building aspects that comes to it, which are interesting to have also there in the hardware project documentation. And then in terms of co-design itself, the main idea is that you have two levels in the design. You have a higher level, which is basically here what I explained with the functional behavioral structural model, which is basically explaining on a high level what the hardware should be doing and how. And then you have a more detailed level where people design stuff themselves, or more detailed, so where you have CAD design and you basically transform this high level design choice into a very specific solution, basically, which include what material you will use, which may include what structure it has, what electronics it will get, what sensors to include at what point. And different people will need different aspect of it. That's I think the main. So the important message there is that you need different levels so that people can enter at different points into your documentation. So if you're basically a user with an ID, you don't need those information. If you're a contributor, which only think about changing or adapting it to your project, it's important to know some stuff, maybe not everything. And if you want to, or this high-level documentation is more important to you because it makes this studying the hardware and understanding how it works much easier than if you just have the CAD files. And if you want to have a very specific change in the design, then you need this very specific design documentation. Right, so it's balance between what is the goal and how much time you have to invest. But in basics, it's like for every research. So engineering is not specific. So it's just people don't like to document, but the earlier you do it, the less time you actually gain. So it's like for research data management in general, people say it's about 5 to 10% of your time that you should invest in that. And other studies show that if you don't do anything, you will lose 15% of your time. And so in the end, doing it, it's plus 5%. But the thing is that the time you earn is mostly at the end of the project, and people don't like to invest time at the beginning of the project for something that will pay off 2 years later. That's very difficult to convince people, unless they work collaboratively, because there it's very important. Otherwise, if you work in a team and you don't document, you turn in circles, especially if you don't meet very on a daily basis. So it's always a ratio, right?
Yeah, exactly. Well, I have more questions, but there's one from Dara, and I'm sure everyone else also wants to ask something.
Dara, should I read your question, or do you want to read it yourself? I'll give you 15 seconds, and otherwise I will just read it. Okay, good. So thanks for your presentation, Julien. I will ask, if you do open source hardware full-time, if you do it full-time, how do you make money with this work, or do you just do it for building stuff? Which is basically a question of, can one make a living of doing research hardware or open source hardware? And I think one could. It's very difficult though, because it requires a different economic system often, because you don't make that much money in selling the hardware itself. So, and people have tried to build different model system. So there is some projects which are really low cost and where you have a big market and where selling the hardware could be enough to make a living. And an example is the farm boat company in the US, where it's open source. It was developed open source, and then they still mostly one company is selling them, because and there the key point was to have a high quality, because competitors could not have that quality. Then there's other kind of models, and this also linked to what is called sufficiency-oriented businesses or research on sustainability models for economic model where growth is not the objective. So try to find a way to make money without having to grow, which is often about selling workshops about your hardware or selling support. And this is also close to what open source software companies are doing. So they're not really making money in selling the software itself, but they are making money in selling support mostly. And there's different model systems that could be applied, but it's still very the exception, I will say. One thing we are also looking at is how different it is, right? So you can also say if you're doing hardware, even if it's not open source, can you make money with it? And in this case, open source has some advantages in terms of time to market, basically. So you don't have to do everything in secret, and you may be able to build something faster. But as I said, it's still very early on for open source hardware to be economically viable and to have really good examples. So, but for Gosh, it's also that we are also working for research hardware in most cases where we don't need to make money with it because that's not the goal. Nicola, you wanted to add something?
Yeah, if there's time, I don't know how much time we have left, but yeah, with Nano Castro, which is also from the Regosh community here in Argentina, we are trying to sell colorimeters and some with other friends, the liquid handler, and yeah, so we are trying to figure out how we will live off of this, but if we can, right? But I feel that if there is something that you could make a living, if you could make a living out of selling the hardware, then the Chinese will do it for you instead. So they will do it because there's a market for that large enough. So I think that the open hardware model will work around developing new solutions, perhaps, and what you said as well, giving support and charging for making new open work. So I've done a robot, someone wants a new tool for it, then it costs something and you put a price on it and people can pay for it. And it's much like software development, perhaps. But yeah, so there are many ways of making a living in general, and it applies to open hardware as well.
And also interesting there is this, if you don't do open source, Chinese, if there's a market, Chinese will still, they will reverse engineer it very rapidly and get it sold too. So it's not because you do it with a patent that you're free of getting people on doing the same things as you are.
Yeah, well, that's the catch is the good thing about what I said is that you charge for new stuff, not the stuff that you did. So you're always ahead in some way. That's one way.
Yeah, it's a very research oriented. We're paid to do the work in advance, basically, right?
Yeah. But well, it's sort of, I think it has many advantages, but well, just that. Sorry for the interruption.
Yeah, I have another question from Fanas. I hope I said the name correctly. Thanks for the presentation, very informative. Did you also check the Godot engine doc and got inspiration with other software project for this also documentation? So there we looked at Git building, but didn't really have new stuff to add. That's why it's not in the list. And I'm personally don't know about the Godot engine docs. That's something I never heard of before. So if you have knowledge, if someone knows about the project, it would be nice to speak up.
Yeah,
Yeah.
Godot is just an open source game engine, and I think
Mhm.
I usually look at like, I mean, I have my open hardware project, so for me documentation is very important, and thank you for the template. So that's why I wanted to know like when you were creating it, you and your team, like, do you always look like at, I mean, open source software documentation has been around a bit longer. So did you get inspiration from other open source projects?
That's basically what came into the Turing Way aspect. So the Turing Way book is a collaborative book which was led by the Turing Way. Or is it the Institute in UK? And there they looked at open source software and open science. So a lot of them are software engineers, and they looked at how to make it easier to document research and software open source. So, and that's where a lot of the community aspect is coming from, and a lot of the project management, because there's basically very similar, whatever your project is. It's about working collaboratively online, and that's this part is very similar for software and hardware. Hardware has a specifics that usually it's more based on local partners. People can build things together, and there is very few examples of really things that were built online, because yeah, you often needs to come together for hardware, and the online component is maybe less important than for software, where everybody can really comes in. But I think that's also something that's changing, because you need more and more skills when you build hardware and get feedback from users, feedback from maintainers, feedback from people that will repair it in the end, that you could include much early on if you would work a bit more like open source software project are working.
Can can you, so right now
Mhm.
I'm also trying to create the like a guide build for this robot that I create for students. And I'm thinking like I should probably like test it, have the students go through it as they're building the robot to see. Can you think like what are some things I should like look for? Like one of the question I had, like, should I create short videos or just put it as short GIFs? Or should I just put like just pictures? Like,
Yeah, we actually have another project here looking directly at the best way to create documentation for assembly. And there's quite a lot of research on it. It's often the critical point is to know in which order you build the stuff. That's very important. And then in terms of the manual itself, both videos and photos may be important, and it's also depends on who will build it. Some people are happy with videos, and others will just never look at them. And the best is to have both, but in if videos are often simpler to create, so if you don't have that much time, I will go for the videos first and then try to make a real manual. And I talked about Git building before. That's a software which is made to create assembly manuals. And there's the workflow is to create the manuals first, and then it gives you the bill of materials, so that when you change something, you change the manual first. And then the rest is derived from the manual, which is an interesting way to keep the manual up to date, because that's often in the long run, the issue is not really to create the first version of the manual, but really to update it when you have a change in the design.
thank you. I also saw Nicola share the stepwise docs here. So thank you both.
So yeah, so if I may interrupt again. So for the robot, one day my cousin who wanted to build it said that he didn't like the wiki. So he made his own tool for documenting open hardware, and that's what's there. So my cousin is a special person. But if you browse the projects there in that site, you can find the pipetting robot, and perhaps you will find some inspiration. The site is more or less like an iFixit thing, but it is multimedial, so you can put also link to YouTube videos there, and it has steps, and you can check boxes and come back and continue from the checkboxes that you left earlier. And making guides is also very easy. This is not a Git building replacement, because I do use Git building, but I do not use it anymore to make documentation because it was horrible. I have to be honest. I love it. I love also love Julien Sterling. He's a great guy, and Git building is awesome. But I just couldn't use it for documenting. It's too awkward. After having tried something else that is. So yeah,
Yeah,
I think you can register there and give it a try.
it's good you mentioned iFixit because they have a really straightforward 5 points you have to take care of, and it's make it so the manuals there are quite good. So it's really about how you make the pictures and how you describe what you have to do, right? So yeah, iFixit is a good first source if you want to come into assembly manuals. I have another question from Michael, which is about incentives for adoption. And the first things to do is to make people know about it. That's why I'm talking today, and I will talk next week at our shop. So then we had a project to help people. I think the main problem with this kind of project is that what Nicolas said in the beginning, right? People come to documentation when the hardware is already ready. And then it's very difficult to invest time in things that you should have done 2 years ago. So it makes more time to do it, and you don't really have the advantages that you would have got if you have done it earlier. So people tend to go to a minimal documentation at that point. And that's something we'll have to work on. So there's some elements. That's why I also have the full template there, so that people can just go through it and say, okay, here I add some things that I take out. Maybe easier at this point. I'm not sure. And we run courses where we want to use it and get feedback from the people. And another idea we had was to create a software from this documentation that will tell you what you have to do, basically. And people looked at an AI-based one. I'm not very keen on that, but that may be a way that you basically have your documentation and the computer will tell you where the gaps are, depending on what your objective is. I don't think we need AI for that, but maybe faster to deploy. I don't know. We'll see how we get there, but that would be one way to go to make it easier to adopt if it was in the form of a chatbot or something like that. But yeah, I mean, I'm very open to new ideas. But I think we need use cases and get the word out at this point. Was there other question? I'm trying to read the chat.
I don't think that there were other questions that came in through the chat. I had one though. which is I was reading the guide earlier this morning. It's morning here, and I was interested that you noted in the guide that you thought that certification would help enable or support discovery, perhaps more so than metadata. And I was wondering if you could explain a little bit why that is. Is it a social reason? Is it a technical reason, or is it both?
I think I wrote that in the idea of what happened in Ho, basically, where there were a lot of different projects, but the quality of the project inside were quite low. So it was very difficult to reuse or to know or to filter out things that were actually reusable from things which would only be able to give ideas, basically. So a lot of projects just were a YouTube video that show what this stuff could do, but not even explain how to build it.
Right.
Right?
Yes, that makes intuitive sense to me. Thank you. So it's a little bit of both, social and technical.
Yeah, and also like in the future you could also, if you had some metadata about how the project are open to new collaborators or things like special tags that were used on during for software. There were some what was it? The Oktoberfest kind of stuff where people could tag their repository as wanting to have new collaborators, and people will just come in and see what's to do there. And I think there's a lot of things to do in terms of opening the hardware development early on, because nowadays hardware are created and then at the end people document it and say, okay, that's there, do something with it. I'm gone. I have a new job now. And that's a lot of the open source hardware is like this, and community dependent hardware projects are still quite rare. But I think it's a process that was also like that for software for a long time, and or it looked like this, at least from outside, that you will just put your stuff when it's ready to be read. And there's also some social aspects that people tend not to share things they're not happy with and want to be finished first. And I think it's basically against the idea of making it together. And I'd love to see more projects opening up much earlier.
Well, that's a nice note to end on. We do only have 5 more minutes. So does anybody else have any additional questions, excuse me, that they want to ask? Any?
Well,
Go ahead.
I could ask. I don't. It's not a question. Perhaps it's a user request for Julien. So, I'd like a heading in the documentation guide that you made for me to know how to read it, what I can expect and what I can use from it. I mean, there's lots of content, and I feel it's a book really to read. And from my experience with the technical documentation template is that for it to be really approachable, you have like it's a good thing to have in the front page a checklist of what you can expect and what you can do with it right at the start. So that would be a suggestion.
Yeah, open an issue.
Right. I tried, but the codework page is
Yes.
giving me a 404.
Yeah, you need to be signed in. That's true. Codeback doesn't allow you to see things if you're not inside, because there's too much AI scrapping. Yeah.
So I only have to log in then.
Yeah.
Okay, great. We'll open an issue then. So what do you think is the most important now for hardware documentation, like the most critical things to develop, to make, to think about?
You mean when you start documenting?
Or perhaps more in general, like for the Gosh community or for the people around you, or perhaps a more open question.
Yeah, I think there's a main for Gosh itself and for academia, the next step is to really have something like the Journal of Open Source Software, but for hardware. We're working on it, but it's a bit more complicated. And it's difficult to find the right ratio between the academic system and the communication system, and how to basically review hardware is a big topic. And yeah, I mean, I don't know. We live in difficult times for research in general, so getting together may be a way to be stronger together. And that's where I'm not sure in which direction the best will be. But yeah, you will have 2 years ago was really about recognizing the work and making new careers and this. But I think we're past that in those time where we must think about resilience and still being able to do the work, to do good work without having to rely on the goodwill of politicians and society in general to help us doing that.
So it's the gathering itself that is critical.
Probably the community is super important, and
Awesome.
making community stronger, and having the good people fight together. Yeah.
I think that's a better note to end on.